Hello and welcome to this Design Practice 2 Module 30. The course, this particular module is dedicated to rapid tooling, rapid prototyping. In the last few modules, we had been extensively looking at CNC programming and processes related to the CNC machine. So let's look at what is rapid prototyping to begin with. So rapid prototyping basically is a new manufacturing technique that allows for fast fabrication of computer models designated with 3-dimension computer-aided software, CAD software. So the idea is whatever we have done towards the beginning of this course, where we have talked about a lot of handling of a lot of data related to surfaces or related to let's say 3-dimensional models, the same coordinate data can be really mapped in form of a direct manufacturing through this process, rapid prototyping. So this process allows fast realization of ideas. Particularly it is used more as a modeling tool for the prototyping stage of the design. Most of the designers are habituated to visualizing 3D shapes, forms, etc. by looking at the rapid prototyping forms because it's easily doable. So basically the idea here is that through a polymer or through metals you can actually formulate a layer by layer manufacturing, so that any complex topology, any complex shape can be reproduced, okay. And the ideas into functional prototypes is basically the aspect of design which is covered using these rapid prototyping techniques. So therefore, because we have functioning prototypes for all the design ideas that you have already discussed and sketched and schematically drawn and also made the computer model, it typically shortens the design time, because a lot of time otherwise is spent in visualization and thinking about what will happen to the final product outlay. So if you have something in hand where you are actually looking at that, which is maybe a demo, maybe a scaled down version, but it just gives you an idea of the whole 3D shape or size or form. So this really is a step towards successful final products. So RP today is used in a wide variety of industries, from shoemakers to car manufacturers, I would say. This is the level and complexity in which RP is used. Some examples could be, for example, can look at this shower head which has been 3D printed using polymer. It's an extremely complex shape, but the form of this particular object, how convenient it is to hold by a user, what is the extent of water pressure that can be dwelt, how well the water can be split, all these things, all these aspects are shown by the shower head. This again a 3D print of an automotive manifold. Just prior to the final designing, okay, it is important that you develop this intermediate step to look at aspects related to flow and other fitment aspects. This part gets into an automotive and fits along with the engine. There are other automotive parts where 3D prototyping is used quite a bit, in order to visualize how the prototype would really look like from design stage to a prototype stage or a component stage. So these are some examples of rapid prototyping. If I looked broadly into what are the kind of techniques which are involved in doing this rapid prototyping, there are either subtractive techniques where you take out material, or there are additive techniques where you remove, instead of removing the material, you add layer by layer and build up the desired design. So when we talk about traditional tooling and manufacturing processes, it is a technique which involves mostly the material removal processes from solid piece of material until the desired design or shape or form is realized. There are many such examples, okay. One could be traditional milling, turning, drilling, computer numeric control, CNC machines. You looked at a lot of aspects of CNC in the last few lectures, electric discharge machining, so on and so forth. These are all subtractive techniques, and you can say that if you want to use these processes for prototyping your design ideas, they could be subtractive techniques for prototyping the design ideas. On the other hand, additive manufacturing or additive machining is probably the new thought in the industry, principle reasons for thinking your deposition rather than removal is the prevention of wastage, which otherwise would be when you are trying to machine an otherwise solid block or shape and removing material as chips. So that gets eliminated in this case once you are adding on, because you can add the deposited amount, the desired amount, rather than extra amount and taking it off. Okay. So that's one principal reason for going the additive way in the manufacturing domain. So it adds layers of materials one at a time to build the solid part from bottom to top. The many examples, one of them which was widely used in the earlier years and still in the electronics industry is used quite rapidly, is the micro nano manufacturing techniques, used as a micro nano manufacturing technique is the stereolithography. Then you have fused deposition modeling, FDM, which uses single or two phase polymer systems, and the polymers are otherwise fed in as wires, obtained from billets, and then they are extruded so that there can be the deposition of the extruded polymer onto a bed using a track which is very well defined through a computer design process. So 3D printing in metals is another area where you're talking about additive manufacturing for rapid prototyping or performing rapid prototyping. There are several advantages and disadvantages of rapid prototyping as such. The advantages could be that the fast and inexpensive method of prototyping the design ideas. You could have multiple design iterations and try to creatively visualize it, and visualization becomes much easier if you have a model in hand rather than mental form of visualization. And then you have physical validation of the design sometimes. Sometimes you're doing reverse engineering and trying to see how the design would come out, okay, in terms of the CAD geometry that has been plotted in space. And so this gives you quite a bit of validation of how a manufacturing method would work on the CAD data. For example, a CNC operation would work on the CAD data. So there is an in-between step here which is less expensive and doesn't cater to the complete reprototyping of the final form once there is an error. So then there is reduced product development time again, which is another very important advantage for the rapid prototyping techniques. There are several disadvantages also. One of the most important disadvantages is the resolution. It's not as fine as the traditional machining process. Traditional machining typically goes to millimeters or even sub-millimeter domain resolution. Rapid prototyping may not be able to give this much kind of a surface finish, but there is a way out. You can think of a hybrid strategy where you add and remove, and that may lead to a reasonable amount of surface finishing. Some of the tools like electrochemical machining and electrodeposition used in synergism, with some synergy, would be able to realize as fine surfaces as about 100 nanometers plus minus average roughness values, as pointed out in the literature many times. So surface flatness is inappropriate when you talk about RP techniques, obviously dependent on the material and the way it flows or extrudes, and there may not be much control unless you use another strategy of subtractively also machining as well as adding, so that the final formulation of the roughness can happen. So what are some of the starting materials in the rapid prototyping domain? Obviously the first material that would come to view is wax, which is easily meltable, flowable, it's easy to machine, it can be resolidified quickly, it can be melted quickly, and in fact there are desktop CNC machines which would actually build models using wax, which was one of the first generation RP tools that started within the industry. Then there are polymers, which are mostly very widely used, particularly solid polymers, which are formulated through curing layer by layer of liquid monomers. Then there are powders that are aggregated and bonded layer by layer. This process is also known as the selective laser sintering process, SLS process. There can be solid sheets that are laminated to create solid parts together. The only catch here is the layer by layer construction of a certain shape or form or size that has been designed through the CAD interface. There are some additional methods in addition to starting material. The various material addition RP technologies use different methods to build and add layers to create solid parts, and there is a correlation between the starting material and the part building techniques which leads to the realization of the final rapid prototyped product. So, how do we classify the different RP technologies which exist? So, you can have one form of classification based on the starting material. For example, there could be liquid based 3D printing process, which when cured layer by layer into solid polymers develop the solid shape or form or size of the final 3D product. There can be solid based materials, particularly laminates, which are bonded to each other to create the solid parts. It could be powder based, where it is still solid, but then granules, and these granules can be sintered to each other very in a focused manner using laser and other light forms, and these aggregated and bonded layers can be again built up in a layer by layer manner, so that the final 3D shape or form can be realized. So, these are some of the classifications of RP tools based on the starting materials. We will go into the details of each of these, probably looking into some of the aspects associated with stereolithography, which is actually a liquid based 3D printing process, FDM, which is again based on a solid extruded polymer, and then powder based, which is again based on lasing action and sintering action. So, I think I will close this particular module, because this was a shorter module to plug the gap which was created in the last week's lectures of about 10 minutes or so. So, in the next module we will start some of the detailed discussion about these individual techniques. As of now, thank you very much.